Good afternoon, everyone. Thank you for joining me today. My name is Iñaqui Delgado. I'm the Android tech lead for the voice and video team at Twilio. I did. Yeah, I'm recording. So the Android ecosystem at Twilio has actually grown quite a bit in the last year or so. I guess one of the applications and SDKs that we provide is Authy. Allows you to do two-factor authentication. Recently, we also have added messaging, which allows you to integrate chat type of applications into your apps. In addition, we have a product called Sync, which allows you to do real-time data synchronization across various devices. Probably what we're most better known for is voice and sort of things related to telephony. And so the Voice Android SDK allows us to make outgoing calls to just regular phone numbers, as well as like VoIP clients, and also receive incoming calls from phone numbers as well as other clients. And today I'm going to be focusing on the video SDK. So earlier this year in January, we released the first version of our Android SDK in a public beta. And since then, we've been doing quite a bit of work. So the video platform uses a very similar infrastructure to a lot of the other Twilio products. And we have this product on Android, iOS, JavaScript. And more recently, we've actually started building this library for embedded devices. So devices that are kind of like your IoT type of devices. So we're excited about sort of that aspect of this platform as well. And one thing to note is we leverage WebRTC, which is sort of the de facto standard for doing real-time audio and video, as well as sort of data channels these days. So I wanted to start by just kind of showing you the canonical, use case of when people think about real-time video. So we've done this a lot, but I wanted to show you just kind of how that would work. So I've got our test app here, the web test app in JavaScript, and I've just logged in, and I'm going to go ahead and connect to a room. And then I've got my phone here, and I'm going to do the same thing with our test app. So just going to connect to the room Android. And there you go. Pretty typical user experience there. So this is probably what most people think of when they think about real-time video, being able to chat one-on-one. There's not really anything particularly special happening here. So, but I wanted to start there. Okay. So what you just saw is actually sort of two aspects of our API model. There's the room model, which is the notion that you can connect to a named resource, in this case, the room Android. And you're actually represented as what we refer to as a local participant. And then any number of participants can join and leave that room at will. And so those participants are represented as a participant. The other aspect of our API is the media, and that's, I think, kind of the more interesting aspect of this. So as a local participant, you're allowed to provide your own local media. And your local media is comprised of tracks, media tracks. And so you can provide audio tracks as well as video tracks. When you join the room, you're actually given events related to the various tracks that are being shared by other participants. So today I actually wanted to focus primarily on the local media and how you can use, how you can make changes to captures as well as renderers to get sort of more unique user experiences for your users. And so I'll be talking specifically about captures. I'll talk about kind of the standard camera capture. I'll share a screen capture that we've added to our SDK. And then I'll go into what would be required to build your own custom capture using our API. And then I'll do walk through renderers and talk about the standard sort of video view render that we provide, and also do an example of a custom render there. And then I'll wrap up and talk about how you can leverage local media in a number of different ways to also create some interesting experiences. So that first sort of demo I just did there, I want to kind of walk through what the actual code would look like. So the first thing you do is you create a video client, and in order to do that, you have to provide an access token, which allows us to have an identity. And next, you'll want to create a local media and instantiate a capture. So in this case, I'm saying, hey, give me the front camera and use it in this camera capture. And at that point, I can create a local video track with that camera capture. And lastly, if I want to preview this video, I can use the local video track I've created and add a local video view that's in my layout and add it as a render. And I'll talk about why you can actually add this video view as a render in a little bit. So at this point, we've got kind of this preview, which you saw earlier. So next, I want to join the room. So there's a builder called Connect Options, and it allows you to specify a number of different options. But the two that I just want to highlight is the room name and the local media that you'd like to share. And so at that point, with your client, you can then connect to the room. And at a later time, you'll get an on-connected callback. And you can start learning about the different participants that are in the room and also start getting callbacks for the various tracks that they're sharing. So I wanted to now sort of talk about some of the customizations you can make to captures. So let's do a quick demo. So in this demo, I'm actually going to add some video constraints to the capture. So I'm going to go ahead, log in, and I'm going to connect to the Android room again. Okay. And now I've sort of pre-baked some constraints in here. I'm actually going to turn off the audio here and here. And what I'm going to do is I'm actually going to change the aspect ratio. So in order to do that, so when you're a participant in a room, you can add and remove tracks whenever you want. So you can add video tracks dynamically or audio tracks for that matter. So I'm just going to go ahead and do that. So you can see, so the aspect ratio that I originally entered the room with was 4:3. And now I've applied some constraints, and I'm doing 16:9. So those are one of a few things you can do with constraints. And we'll talk about a few more now. So what I just did there is I used a video constraints builder, and I've specified an aspect ratio of 16:9. You can do a couple other things. You can actually constrain like the number of frames per second that the capture is providing to the track. You can also specify various dimensions that you may want to use. So it's actually a pretty useful thing to do. Okay. So next, I wanted to show you a screen capture example. So let's see. Okay. So I'm going to go ahead and hit the screen capture icon up there. So that little guy right there. And I'm actually going to get a dialog. So here I'm using the Screen Projection Manager, which was something added in, I believe, API 21. And what it allows you to do is actually get the window of your phone. So I'm going to head and hit Start Now. And so now the capture is actually capturing the window on my phone. So I'm going to go ahead and connect to the Android room again, and we should see that. Okay. So if I navigate away, looked a little bit weird there, but if I navigate away, I can go into Ways, and you can kind of see it being rendered there. So that's pretty cool. And you can think of use cases like maybe tech support, but it's kind of weird too, right? Like, why would you want someone to see your entire screen? Like, so can we do better? And the answer is no. And I just leave the no. We can do a little better. It's not going to be that much better, but.
Can you control the quality of the video, or is that something that's handled by WebRTC?
Yeah, so WebRTC will do a lot sort of under the hood, sort of calculate like bandwidth and bitrate and sort of modulate that. So if I had stayed on here, if I had actually stayed in the room for a significant amount of time, you may have actually even seen it downscale. So go from like VGA to like 320 by 240 or something like that. So, but the one thing you can do is sort of like apply some common sense constraints up front. So if you know that most of your users are on like much older devices, why start at a high resolution or even a fast frame rate? So, all right. So let's see here. Okay, so first let me talk about what I just did there. So I mentioned the Media Projection Manager. So this is a system service. And the way that you can actually initiate this screen sharing is by calling into the Media Projection Manager and actually obtaining a screen capture intent. And once you have that intent, then you can provide this intent to our screen capture and then add it to the video track like you would have with the camera capture. All right, so I mentioned, you may not want to share your full screen all the time. So what if you can just share a view, right? So you can think of use cases, maybe someone's playing, maybe you're a game app developer and you want to share the screen associated with the game they're playing, right? So let's see how that would work. All right, so hopefully this is the right demo. Yeah, so what I've got here is on the top is just a regular view with three different, there's a text view with a timer, there's a checkbox, and then there's an edit text. And below, I'm actually, so I'm capturing this view. I think I've set this up for 10 frames per second. And I'm creating a local video track, and then on the bottom here, I'm rendering it with the standard video view. So this is kind of a sort of a different way to do screen capture without using the Media Projection API. So in order to implement your own custom capture, you have to implement an interface we provide you called video capture. And as long as you do that, you can add your capture like you did before. In this case, with view capture, I'm actually providing the view that I'd like to capture. Let me hit play here. So this video capture interface isn't super complicated. It requires that you implement three methods. So get supported formats is something that you provide to us to tell us what formats you support. So this actually is sort of a triple of information. So you provide the video dimensions that you're giving us, the frame rate that you're planning to use, and the pixel format, which is sort of more related to the display that you're using. And then in addition, you'll implement start capture. This will actually be called by us, and this will allow you to start whatever sort of run loop or event loop or thread loop that will provide us with frames. And then stop capture. So when you call add local video track on the local media, we'll actually call start capture. And then at the bottom here, the listener is actually something that you use to provide us with information. So when we call start capture, then we want you to tell us when you've actually started the capture, because you may try to start it and it may fail. So at that point, we need to know. Once you've started it, you can then start providing us with frames by calling onFrameCaptured. So I kept saying, us and we. And so what I'm really actually talking about here is, so we actually use the power of WebRTC, the Google's Chromium WebRTC implementation. And so sort of under the hood, what we're doing is when you call add video track, we're actually going down into using JNI, and we're creating a delegate, which will then allow us to call back to these methods, the start capture, the stop capture. And we're actually using a standard Cricket video capture. So we're creating an Android video capture using the delegate that references your Java object. And so when you add things to the local media, we're able to then call back up and do the right things. So that's how the interface works. So now let me talk about how the actual view capture itself works. So I mentioned we're going to call start capture when you call the add local video track. And we're actually going to provide you with that listener so that you can tell us that you've started your capture. So here I actually have a handler, and I'm actually going to start this runnable. And this frame rate here is set to run, in this case I think I've set it to 10 frames per second. So every 100 milliseconds, this runnable is going to run. So in the actual runnable, what I'm doing is I'm obtaining a bitmap from the view. And I'm doing all of this in Java, which you may not necessarily want to do that. But for this example, I'm creating a bitmap based on the size of the view. And then I'm using a canvas to actually draw the contents of the view onto it. So at that point, I've got my bitmap with the data from the view. And now I just need three things. So I need the buffer from the bitmap, which is kind of like a raw byte array. I need the dimensions of the view. So I go ahead and create that. And then I need a timestamp that indicates when that frame was captured. So I'm using the system clock in this case. And so at this point, I now have what's considered the video frame, and I can provide it to the internal Cricket video capture that I mentioned earlier by calling onFrameCaptured. Okay, so spent a lot of time on capture. Let's talk about rendering now. So we've seen a lot of rendering so far. So rendering's also pretty straightforward in terms of the API. So once you have a local video track, you can add as many renders as you'd like. And most renderers, will render to views, but you can also do some custom things. So the video render interface itself is actually really simple. It has one interface method called render frame. And so when you create a local video track, it's being fed by frames, either from your local capture or from a remote stream, right, coming in from, in this case, the room. And so what will happen is as the video renderer, you'll get these calls, render frame, and so you'll be able to take the frame and do something with it. We also provide a listener, and this is really to sort of help like the user experience. So a lot of times if you've used an app, like you may want to actually animate, not necessarily when you get the track, but when you've actually received the first frame. Because a lot of times there's sort of this like setup time, latency. And so we have these listeners so that you can sort of, I guess, provide a better like user experience when you're starting to render your video. So the video view, as I mentioned earlier, is a render. And what we do is we implement this video render interface, but we also leverage an existing renderer that's provided by WebRTC. So we actually think that the WebRTC library itself is really powerful, and so we leverage it wherever we can. We don't want to like reinvent things that already work really well. So recently, I've actually gotten quite a few requests for a particular feature that did require thinking about how to write a custom render. So this particular customer reached out to us and said, hey, like, we want to do some image processing on the frames that we're getting. And in some cases, we want to do it on the local streams that we're getting or even on the remote streams. So the question was, is there a way that I can like take a snapshot of what's being displayed? And so what that really means in the case of this customer is he wanted to take the frame, which is this I-420 frame, and then convert it to a bitmap that he could then post-process and do something with. So in this case, I'd like to show you kind of an example of that. So I've got this pretty simple sample app, and I can actually just tap the screen, and whatever frame is being provided to the renderer at that time, it will actually take that frame and convert it to a bitmap. So, okay. So as I mentioned, I called it the Snapshot video renderer, even though it's not really rendering anything. It's just periodically taking a frame. And I've left out a lot of sort of nuances, like if you keep references to frames, you're not necessarily freeing the memory. So there's a lot of kind of things that you have to keep track of. But the general idea is that you'll get frames, and if I hit this button, I'll call take snapshot. It'll take whatever frame is available at the time and put it into this image view. So in order to do that, I actually needed to write a function that took this I-420 format that WebRTC uses and converted it to a YUV image format, which is what the Android graphics library uses. So that's the first step. The benefit of converting to this YUV image is that you can actually then go to a JPEG, and so this is like almost like a 3 or 4 step process. So then we actually end up with a JPEG, and we can create a bitmap from that stream. And then lastly, when you convert to a JPEG, the rotation information isn't actually there. So then you need to apply whatever rotation is needed. And then at that point, you can create your bitmap, and that can be placed into the view. So I talked a lot about, captures, renders, how to customize some of these things. And the last thing I wanted to touch on today was how you can leverage this local media in different ways. So the local media and the room model are written in such a way where they're in some ways almost completely separate components. So you can actually use your local media across different clients with different identities. So you could have a John and Jane both using the exact same local media. You can also use the same local media to enter different rooms. So you could actually be in 2 rooms sharing the same streams. So there's any number of permutations. You can create multiple instances of local media and provide different capture functionality. And so, I feel like this actually provides a lot of flexibility to the kind of use cases that people are starting to think about with real-time video. And so I'm excited to see what all of you come up with. So I want to end by just recapping. So I talked a lot about just customizations with captures and renders, and then lastly, how to use the local media in a number of different ways. All of the stuff that I've talked about today is actually a developer preview. And so if you go to twilio.com/video today, this is not what you'll see. You'll actually, when we started the year, we shipped an API called Conversations. And since then, we've realized that there's a much better approach to doing video. And so long-term, we'll be moving towards this API. And that'll actually be happening in the coming weeks. So I really encourage you to write this link down, and this will send me an email, and I'll send you guys the information for accessing this preview. So thank you.